record this and put it on my YouTube for you guys, if that's all right. All right. I checked the, let's do my whiteboard. There are 10 true false questions. There are 22 multiple choice questions. There are 5 fill in the blank. And there are 4 out of 5 short answer questions. And 1 bonus question at the very end. So yay. I think some of the questions you would be able to anticipate, definitely. I think like at the very beginning of ANOVA, when we did the whole naming of ANOVAs thing, and I told you that I'm going to describe a research study, and you need to tell me what kind of ANOVA we need to do there. I think there's like 3 or 4 multiple choice questions along those lines. Boop, 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 boop. Yep. What can I do to help y'all?
What's the bonus question?
It is I'm getting you guys to come up with an example of something. What else you guys got?
Can you explain again what you do, like when the degrees of freedom, the exact one that you're looking for isn't on the sheet?
Yeah. You always go for the one that has fewer degrees of freedom. Right. So let me stop the share and let's see if I can find a T table or an F table. Oh yeah. Here we go. Okay, you guys see this one and see how ugly it looks? So let's say that we go down here and we have 4 degrees of freedom in the numerator, and we have 50 degrees of freedom in the denominator. I don't see that, so I'm going to go for the one with 40 as opposed to 60. So I always go for the more conservative option. Sound good? Although this would not be a good one because this is for an alpha level of 0.1. And we do not have an alpha level of 0.1. We have an alpha level of 0.05. You also see that the F table that I gave you guys is a lot more attractive than this thing. Did that help?
Yeah, thank you.
Thank you.
For like the true or false or multiple choice or anything really, is like, can we find it in the book or is it just what you went over in class?
Mostly what I went over in class. I did check. So questions from the book. I think I've got 2 directly from the book that I have not mentioned in class.
Okay.
I think 1 multiple choice and 1 true false.
What, like, I don't want to ask like what's on it, obviously, but like what specifically, just like everything you've covered the last couple of weeks?
Just on the test overall?
Yeah.
Yeah. So stuff that I covered in the last couple of weeks, all on ANOVAs. Why do we do ANOVAs? What's an F all about? Why do we, yeah. So things like that. Give me the specific analysis of variance when we have this particular problem. Stuff like that. a couple of people in the study session were like, what are the short answer questions going to be? And I go, well, guess. And they guessed a few, and I think they guessed like 3, and 2 of them are going to be on the test. So I think that you got a pretty good idea of the kind of stuff that I ask at this point in time. Okay. So hopefully that was helpful, Grady.
Yeah, it was.
Yeah.
Thanks.
From Cadence. In 2x2 between subjects and ANOVA, how many effects do we calculate F statistic for? What are these effects? How many sources of variance are there in a one-way within subjects and ANOVA? What is our error term? Oh, this sounds like something from the practice problems. Okay. Let's do that. So we've got 2x2 between subjects and ANOVA. Let me not do caps lock. All right, we've got 3 effects, right? Main effect 1, main effect 2, and interaction between the 2 things, right? Those are the 3 effects that we have. Okay. How many sources of variance do we have for a 2x2 between subjects and ANOVA? Well, sum of squares total is equal to sum of squares for the first effect. Okay. Plus sum of squares for the second effect, plus sum of squares for the interaction. Okay. And I wanted to do that in like the small font, but bear with me. And then the sum of squares for within. Okay. For the 2x2 between subjects and ANOVA, what is the error term? That's right. The error term is the sum of squares within. Can I bold that? Nope. Okay, well, we'll just go with that. How many sources of variance are there for a one-way within subjects and ANOVA? Okay, well, sum of squares total for within subjects and ANOVA. That's the sum of squares for the independent variable, the sum of squares for the effect. There's sum of squares for subject that we're able to account for because we're doing it within subjects and ANOVA. And then we have a sum of squares of subject by effect. All right, so 3 sources of variance that makes up the total amount of variability for sum of squares total. And I'll throw that question back to you, Cadence. What is my error term for a one-way within subjects and ANOVA?
Sorry, it's Elizabeth and Cadence, so we're both trying.
Wouldn't
Okay.
it be okay, I might be so dumb here.
You got it. You got it.
Is it the effect?
So the
No.
effect is in the numerator, right? So that's
So is it the within or no? Because the within, so it's the sum of squares subject by effect.
yep.
Oh my
Okay.
gosh, guys!
Well, that was loud. Okay. Yeah, it's the interaction of subject by effect. Okay. We're removing the sum of squares subject from the analysis entirely, which is one of the advantages of doing a one-way within subjects and ANOVA. Okay. Helpful?
Question. May I ask one quick question?
Please do.
For the one before, for the 2x2 between subjects and ANOVA,
Mhm.
I thought that for like the formula for the sum of squares total, that sounds like our almost like our factorial ANOVA. Am I going crazy?
So you are going crazy. I hate to tell you that.
Oh.
Okay. Any fact. Okay. Do you mind if I erase things? Or let me go over here. Okay. When I say a factorial ANOVA, what I mean is any ANOVA with 2 or more independent variables. If I can spell. So a 2x2 between subjects ANOVA is a type of factorial ANOVA. A 3x2 within subjects ANOVA is a type of factorial ANOVA.
Oh my gosh, thank you so much.
Yeah.
Now I feel really dumb, but that
No. So all the ANOVAs that we've talked about here, so the only one that we talked about calculating was the simplest one, right? So the 2x2 between subjects and ANOVA. But you are armed with all the skills you would need to at least kind of figure out what's going on with any kind of factorial ANOVA, right? So when we were naming ANOVAs, as long as they had 2 or more independent variables, they are factorial ANOVAs. So that's like the umbrella term.
Now I get it so much more now. I am so sorry. That is
No.
probably something I should have known before.
No. That probably helps 100 or more people.
Okay, thank you so much.
No problem. What else you guys got for me?
Could you like quickly go over the multiple comparison procedures that you talked about? It was like towards the beginning,
Oh yeah.
like, when we use them.
Yeah. Okay, cool. Boo. So, you guys mind if I delete some stuff? I say as I'm actively deleting things. Okay. So, what are multiple comparison procedures? When we have an ANOVA and it's significant, we don't know where those significant differences are. It could be all of our conditions are significantly different from one another. It could be only 2 of our conditions are significantly different from one another. We don't know if we have just a significant analysis of variance. Multiple comparison procedures are about hunting those down. But they're about hunting them down in a responsible, statistically responsible way, controlling for type 1 error. Okay, so multiple comparison procedures. Okay, hunting down the significant differences while maintaining adequate type 1 error control. All right. Now we mentioned that there were 2 major types of these. Okay. We have a priori comparisons and we have post hoc comparisons. Okay. A priori comparisons are comparisons that we make beforehand. All right. We call these planned comparisons. Right. So I want to look at just these differences here and these differences there. All right. We didn't spend too much time here because no one can quite agree on the correct way of doing this. But we did spend a decent amount of time about post hoc comparisons where we have the significant ANOVA and we want to hunt them down. All right. We talked about 3 kinds of multiple comparison procedures, but there are tons. And the 3 that we talked about are Fisher's least significant difference, or LSD. We talked about Tukey's honestly significant difference, or HSD. And we talked about the Bonferroni comparison, or the Bonferroni-Dunn comparison, depending on who you ask. All right. So these are these are different ways of doing multiple comparison. All right. We mentioned that as they go down, they get more conservative. As they go up, they become more liberal. So Fisher's LSD is the most liberal. Bonferroni-Dunn is the most conservative of the ones that we've talked about. Okay, what do I mean by liberal and conservative? Liberal means more power. Okay, so as we go up, we have more power. We're more likely to find an effect. More conservative means better. Type 1 error control. I could have typed it out, but there we go. Yes. So Kate says, if Fisher's LSD, that means that we might have a problem with type 1 error. You're right. Okay. How does Fisher's LSD control for type 1 error? And the answer is it doesn't. Okay. There is no type 1 error control. Right. Fisher's LSD does a good job when we have 3 groups. All right. If we've got 4 groups, nope, does a bad job. Does not control type 1 error good enough. We've got 3 groups. Fisher's LSD is perfectly good. It gives us the most bang for our buck. Okay. If we've got more than 3 groups, okay, so 4 or more, we want to do Tukey's. Okay, and we want to avoid Bonfermi done unless we have to. Did that help? I think.
Yes.
Yeah.
Yeah, it helped.
Cool. What else you got?
I mean, if you don't mind, I think also going quickly through like the naming of ANOVAs again, just because like
Yeah.
it was a while ago.
Yeah,
Just like
no
a
worries.
refresher.
I can do that. Do you mind if I go over Rebecca's question first?
Oh yeah.
So Rebecca's question, I'm going to erase clear all my beautiful pictures. Okay. So where was I? Sphericity. All right. So typically we've got 5 assumptions for parametric testing, okay, that I forced you guys to learn for the last test. All right. With ANOVAs, we've got those same assumptions, but when we have a within subjects manipulation or within subjects ANOVA, so we've got at least 3 groups, there is an additional assumption. And the additional assumption is the assumption of sphericity. Okay. What does sphericity mean? It means that the population variance of all our different scores are the same. Okay. So if we've got 3 groups, so we measure people, let's say that we measure people when they are 6, we measure people when they're 8, and we measure people again when they are 10. So we've got a within subjects design, we've got 3 groups. So for within subjects designs, we calculate different scores. Okay, we take people over here when they're 6 and subtract their score when they're 8, and that's our different score. Maybe that's our first different score. Now we do it again, 6 and 10. We subtract 6 from 10, and then we're going to say that this is different score 2. And to finish it up, we're going to take the scores of when people are 8, subtract it from the scores when people are 10, and this is our third different score. Okay. So at the level of the population, if we were to do this for everybody in the population that we're interested in, the different scores would have the same variance. Okay. They would vary just as much as one another. Okay. That is an assumption built into the statistic. If we violate it, we might come up with the incorrect conclusion of our ANOVA, and we need to do something to correct for violating that assumption. And SPSS has a lot of different ways that it might potentially correct for violating the assumption of sphericity.
I actually have a question about that, if I may ask.
Yeah, please do.
So with the sphericity, sorry, is it basically like homogeneity of variance?
It is very similar in that regard, right?
Okay.
Homogeneity of variance is that just not the variance of different scores, but the variance of our scores in general is the same at the level of the population. This
Okay.
one says something very similar, where instead of regular scores, it's all the different scores. The variance is the same at the level of the population.
Okay, so it's just less broad, I guess, because it's
Yeah, because it's
less
different scores.
score. Okay, cool. Thank you.
No problem. Thank you. Thank you. Boop, 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 boop. Okay, so back to Carson's question. I'm going to erase all my beautiful drawings. Okay. So when we're naming a nova, there's three things that we care about. Okay. The number of independent variables. Okay. That's thing number one. Two is the levels of each independent variable. And the last one is how IVs are manipulated. Okay. So if I have one independent variable, what do I call my analysis of variance?
A one-way ANOVA.
Yeah. One way ANOVA. Okay. If I've got two independent variables, all right, a shorthand way of doing this is to call it a two-way ANOVA. Okay. But we get a little bit more specific, and we'll move a little bit more specific as we move down. Okay. So for instance, if I have three independent variables, right, my ANOVA is going to be a blank by blank by blank. I've got three numbers there. Okay. If I've got five independent variables, I'm going to have a blank by blank by blank by blank by blank ANOVA. Okay. You would never want to do that. That'd be crazy to analyze, but just to give you a flavor here. Okay. The levels are the specific numbers here. So for instance, if I have a 2 by 3 ANOVA, how many independent variables do I have? I've got two because I got two numbers. The first independent variable has two levels to it because I see the number 2 here. The second independent variable has 3 levels to it. All right. And I could just as easily call this a 3 by 2 ANOVA. Right, which independent variables number 1 and number 2 is completely and utterly arbitrary here. Okay. Last thing. If all IVs are manipulated between subjects, I have a between subjects ANOVA. All right. If all IVs are within subjects, I have a within subjects ANOVA. Okay. If at least one between subjects and at least one within subjects, I have myself a mixed ANOVA. Okay. So those are the three things that we need to know when we are naming the ANOVAs. Cool. That makes sense?
Yes, thank you.
Yeah, no worries. Melissa, what is the context of that? Total variability.
In my notes, it was basically when you were talking about how between groups will have certain variability and then within groups will have certain variability, but I don't remember exactly.
I know what you're talking about now. Sorry, I didn't know where exactly you're talking about. Okay. What is an analysis of variance? We're looking at all the reasons why people differ in the study. Okay. Why do people get different scores? And we're putting them in different camps. We're attributing it to some different things. Okay. So for a regular one-way ANOVA, we take the total amount of variability and we put it into only two camps for the original ANOVA. We put it into between groups variability, and then we bring it down into within groups variability. Okay. And then what we do is, I'm going to erase some things. We put between groups variability on the top of the F ratio. And I'll just say like variance there. And then we put within groups down here. Within groups variability. Now, I believe what Melissa's asking is like, let's break these down more. Why do people differ between groups? Okay. Well, they differ because of the independent variable, right? The independent variable is different for groups. But there also might be differences just due to random chance. Right? Maybe those means are just different because, okay, you guys remember when we did the example with UNG and UGA for psychology test scores? Maybe we just got a difference just due to, sampling error. Okay. Why do people differ within groups? All right. Well, people differ within groups just due to random chance. Okay. And this random chance in an ANOVA is calculated so that it should be about the same here and here. So if the IV has a big effect, my F statistic is going to be what? Yeah, gritty.
Are we going to have to know these formulas?
Not this one, really. I would ask you to know like what goes into between groups variability, what goes into within groups variability, what goes into random chance, which we're going to get into it to a moment. But you don't need to know these specific formulas.
Okay.
I think what I do is I do ask you some questions about degrees of freedom on the test. I do ask you, I don't want to say that exactly. What do I want to say? No, you don't really need to know the formulas. Okay. I ask you about the degrees of freedom in a couple of places. And yeah, I think that's it. I don't want to give too much away. I'm sorry. Yeah.
No worries.
Okay. Okay. So if the IV has a big effect, what's going to happen? What's going to be bigger, the numerator or the denominator?
The numerator.
The numerator. And if the numerator is bigger, that means F is going to be greater than 1. And that means that we're going to reject their null hypothesis and we're going to be happy. Okay. How about if the independent variable has no effect whatsoever? And we just X that out. Well, that's random chance over random chance. and anything divided by itself is 1. So if there is no effect, f is going to be close to 1, and so we're going to retain the null hypothesis. And that's going to make us a sad researcher. Poor us. Okay. Let's go and talk about what's in random chance. Okay. Why do people differ in their performance within groups? We broke down random chance into 2 things.
Individual difference?
Yeah, individual differences. People are different. Some people are more extroverted. Some people are better at math. All kinds of individual differences. People are not the same. That's one of the reasons why people get different scores. Okay, that's in the random chance sort of category here. Okay, that's cool, but that's not everything. Okay, why else might people differ?
Experimental error.
Yeah, there you go. Okay, so maybe the experiment was not conducted exactly the same way. So we've got experimental error. And so we need to control for so that's why we get within groups variability. Okay, the experiment's not conducted the exact same way every single time, and people are different. Okay, so that's what goes into random chance. And Melissa, I think that's the question you wanted to ask me.
Yes, thank you.
No problem. Okay, good.
I have a question.
Okay.
So I thought the individual differences and the experimental error was for only within groups.
So they are present within groups, but if we look between groups, right, there's different people in both of these conditions, right? So there is individual differences there, right? There's also experimental error between groups as to why people might differ as well. But the critical thing is that we've got the variability due to the independent variable.
Oh, okay, that makes sense. That makes sense.
Okay, I hope that makes sense.
Mm-hmm.
Okay. What else you guys got for me?
Can we go over interpreting and interactions, please?
Yeah,
Thank you.
no problem. Okay. So let's go and erase my beautiful artwork. Okay. So I'm trying to think of what I want to do. Okay. Oh, Spotify Wrap just came out. So let's do number of listens on the y-axis. And then we have early in the year. So early in the year and later in the year. And then we're going to have 2 musical artists. Which 2 musical artists do we want to have?
Tyler, the Creator.
Okay.
Kanye and Taylor Swift.
Was that Taylor Swift? Okay. My boy Tyler is going to be in red. And we're going to put Taylor Swift in green. Okay. So let's say that we have something that looks like this. Okay. So there's our beautiful graph. Is there a main effect of time of year? Well, let's look at it. Early, if I look at listens, the average is probably that, right? Later, the average is probably like that. Are those different from one another? No. No, there is no main effect of time of year. Is there a main effect of artist? No, it's okay. Don't worry. Oh, no. Crap. There we go. Okay. I just want that one. Okay. Go by. Okay, cool. All right. So, how about is there a main effect of artist? Do people listen to Tyler the Creator or Taylor more?
Wouldn't it be an equal amount?
Yeah, it would be an equal amount, right? So let's average Taylor Swift's here and here. So that would be around right here. And if I do Tyler the Creator here and here, the average would be around right here. They're right on top of one another. Do I have a main effect of artist?
No.
I do not. You are correct. Okay. So let's be careful about my erasing. There we go. Beautiful. However, do I have an interaction?
Yes.
I do. So just looking early in the year, who are people listening to more?
Tyler the Creator.
Yes. How about later on?
Taylor Swift.
That is correct. It has flipped. And since it is flipped, Melissa, what kind of interaction is this? Sorry, I'm putting you on the spot.
Is it a crossover? I don't
Yeah.
know.
It is a
Okay.
crossover interaction because the
Uh-huh.
main difference is crossover, right? So I would call this a crossover interaction. I would call this a disordinal interaction. I will call this a qualitative interaction. Okay, cool. You ready for something else? Okay. Hearing nothing, we'll erase this. We'll keep the same setup so I don't have to think of another one. Okay. Mm-mm-mm. They're not the most straight lines, but you know, we do what we can. Okay. Is there a main effect of time of year?
Yes.
Yeah, there is. Okay. Early is about right here. Later is about right here. That is an improvement. People are listening more later on in the year. So I've got a main effect of year. Is there a main effect of artist? Yes. Who do people listen to more?
Taylor Swift.
Yes, Taylor Swift. Okay, now here's the critical question. Is there an interaction?
There is not.
Hmm. Let's look at the difference here. All right. Who's outperforming who?
Taylor's outperforming Tyler.
Yes. How about here?
Taylor is outperforming Tyler, the creator.
Same thing. But is it to the same magnitude?
No.
No. There's a difference in magnitude. And because there's a difference in magnitude, this is still an interaction. But it's not a crossover interaction. It is an ordinal interaction, or we would call it a quantitative interaction. Yay. Is that yay for understanding? Or is that yay for Taylor Swift? I've used Taylor Swift for a lot of my examples in quant and cognitive psychology this semester, and I don't know what that says about me.
Well, I'm saying yay because I finally got it right, which is very rare in the interacting and figuring those out. So
Okay, well,
I
good.
was
I
happy, but
am happy.
yes.
Okay. I think Melissa started that one. Is that helping, Melissa? Is there something else I can do here to help you out?
Yeah, so just to clarify, the crossover and then the quantitative so those two, they both have some sort of interaction effect.
Both of these are interactions, right?
Yeah.
So
Mhm.
if it is not an interaction, that means that the difference is the same for some. So let me give you, and let me show you that. Give me, well, let's see. Grady, what's your question?
So what would both of these fall under, like the main category?
They would both fall under interactions. Both of
Okay.
them would be statistically significant interactions, right? But let's see. We see this. We'll give some love to Tyler this time. Igor was a great album. So was Call Me If You Get Lost. That was fantastic. Okay. Okay. Is there interaction here? That's the question. For early, Tyler's doing better. And he's doing better by this much. Later, again, Tyler is doing better, but Tyler's doing better by the same amount. That amount has not changed. And I know my drawing is horrible and it's probably not exactly the same, but you see how this difference is the same as that difference, and the lines are parallel to one another. That means no interaction. But oh no. Okay.
So there's only an interaction when they cross, or there's a difference in magnitude?
If there's a difference in magnitude, there's an interaction. They do not have to cross. If they cross, it's a crossover interaction.
Okay. Thank you.
No problem. Where's my colors? There's my colors. Is this an interaction?
Yes.
Yes, it is. It is an ordinal interaction. Tyler's still doing better at both periods of time, but that difference has changed going from early to later. Cadence in response to what? So main effective artist here.
Okay, so that was the one before. It would just have a main effective artist and
Yes. Main
Cool.
effective artist and probably a main effective time as well, if both are increasing.
okay.
Yep. Sorry, I didn't see your chat till later.
You are good. You good.
Hmm.
How is Pax doing?
He's doing fantastic. Can I show you guys him sleeping? Let's
Yes,
see.
please. Oh.
Can you see him? No.
No, it's
No.
glare.
Okay.
We can
That-
see a small outline.
Yeah. Do you see he's asleep and his arms are behind his head.
I see that now. Oh my gosh.
Yeah.
see
He
his-
sleeps like this sometimes.
Yeah, he looks like he makes like $1 million
Yeah, he's like, it's been a good day.
at the office.
Yeah.
Dr. Harrison, I have to tell you.
Yeah.
For my Spotify Wrapped,
Mhm.
Tyler was my second top artist. So
Oh, you want to?
Yes.
Well, let me show you my. Oh, let's see. Let's stop the share and let's put this up. Can I?
So I have Apple Music, but I
Yeah.
think you can probably guess what my number one artist was.
Who is your number one artist?
Deftones.
Oh, good.
Professor Harrison, I'm
Yeah.
willing to put 5 extra points that MF Doom or some other rapper like that is on your top 5.
Yeah, you'd be right. Madlib, who worked with MF Doom, is number 4 on mine, if I remember correctly.
so that's 5 extra points I hear on the exam.
What's your favorite rap album? Is it like Illmatic or one of the classics like that?
Oh, that's hard.
Okay.
Give me a second. I was going to pull up my.
This is so Quant related, guy.
It's not. Is it?
You should add a bonus question, like 5 extra bonus points, and it's your top 5 bands or whatever.
Yeah, I second that.
Can you guys hear that?
Yes.
Yes.
Okay,
What
let
is
me
happening?
stop that. Okay, my apologies for that.
That's good.
I was trying to pull it up without it doing anything.
He's
Let's
like,
see.
It's unmuted. But Peter's big mad.
that's Roger.
Oh, is it Roger?
I'm sorry, we're talking about my cat. Anyway.
Oh no, he's coming to get me.
That's mine.
Oh. Ooh.
So we have the same. Wow.
Yeah.
I
I'm
was
gonna show
I
you
was
that.
right about Nas being somewhere.
Yeah.
Kendrick Lamar, a good choice.
Yeah,
Pretty
that's
good.
my rap. My apologies for the music playing earlier. I was trying to cut it off.
Those are some awesome choices.
Thank you.
All right, I'm memorizing that for 10 extra points.
Yeah, I don't know a single one of those songs, which means they're probably actually good.
Yeah. I just to share.
Yeah.
All right. So that had nothing to do with Quant. Is there anything else I could help you with?
I see some Word documents of quantitative methods and different things. You should open those.
I probably have the
So are you
test
gonna
there.
are you gonna post this on your YouTube like as soon as?
Oh, I should. Yeah. That's the plan.
All right, cool.
It
Thank
takes a
you.
little while to upload it though. Just heads up.
Yeah, no worries.
Cadence and I are good with questions. We thank you.
Okay. Can I go over to degrees of freedom for within ANOVAs? I can do that. Sorry, I was distracting you with my musical preferences and not answering questions. For within ANOVAs, okay, We talked about degrees. Whoa, that is way more. There we go. Okay. So we've got degrees of freedom total, which is equal to the number of subjects multiplied by the number of conditions that we have minus 1. We've got the degrees of freedom for the effect, and the degrees of freedom for the effect is J minus 1. Degrees of freedom for subject is equal to n minus 1. And degrees of freedom for subject by effect is equal to J minus 1 multiplied by n minus 1. And I know my handwriting's really, really bad, Riley. I apologize. Did that help? Cool beans. All right. I hope you guys good luck studying, and I will see you all tomorrow.
Thanks.
No
Bye.
problem. Thank you.
Have a nice
Thank
night.
you.
You too.
Have a good night. Bye.
Thank
Bye.
you.
Thank you.